We want to look at several ways that regulation of blood pressure is going to take place long term. The first one let's look at is renin, angiotensin, aldosterone mechanism. Okay, let's set up our little equation here. We have angiotensin. It will be converted to angiotensin 1, which is converted to angiotensin 2. Okay, both angiotensin and angiotensin 1 are inactive, but they're converted eventually to angiotensin 2 if these two things are going to be present. The two things we'll look at. Angiotensin 2, though, is active. Okay, what converts angiotensin to angiotensin 1? This is renin. Okay, where does renin come from? Angiotensin, just by the way, I forgot to say this. Angiotensin is in the bloodstream. Just plain angiotensin is always in the bloodstream. Renin is secreted by the kidneys. It's secreted by the kidneys when blood pressure is too low. When blood pressure is too low, the kidneys try to increase the blood pressure. And when we get to our urinary system, we'll see why the kidneys need a certain blood pressure. But the renin is secreted by the kidneys. That's going to convert angiotensin to angiotensin 1. Angiotensin 1 is converted to angiotensin 2 by angiotensin converting enzyme. Angiotensin converting enzyme is also known as ACE. Okay, so what is active angiotensin going to do? It's going to do two things. Number one, active angiotensin is going to cause aldosterone to be secreted. We know aldosterone already as being our long-term stress hormone. Aldosterone is going to tell the kidneys. It tells the kidneys to reabsorb sodium. And with that sodium, water comes by osmosis. This is going to increase the blood volume, which increases blood pressure. A second thing that angiotensin is going to do, it causes vasoconstriction. Vasoconstriction is talking about the blood vessels are going to constrict, so the veins constrict. Where does the blood go if the veins constrict? Then it's going to increase the blood to the heart. When blood is increased to the heart, that increases venous return. What goes in the heart must come out, so increasing venous return is going to increase cardiac output. Increasing cardiac output will therefore increase the blood pressure, because we know that mean arterial pressure equals cardiac output times peripheral resistance. Okay, another thing I would just want to point out on this one is ACE. This is another drug classification, or this has to do with a drug classification. ACE inhibitors. Okay, ACE inhibitors are going to inhibit the angiotensin converting enzyme, so it does not activate angiotensin, and our steps 1 and 2 cannot be done there. Okay, another thing too, just to make note, vitamin D inhibits angiotensin converting enzyme. So they say that vitamin D can help control blood pressure because of that reason. Okay, I need to erase the board so that we can go to a couple of other ones. Okay, the next one we'll do is kind of an easy one. We're familiar with it, is ADH. ADH is also known as vasopressin. Remember that blood volume determines blood pressure, so any of your hormones that have to do with blood volume will be included on this list. So we have vasopressin. Vasopressin, like I said, is the same thing as ADH. If you have high blood pressure, that could be because you have a high blood volume. Your brain, your posterior pituitary, well, it will secrete less ADH. Remember, ADH is going to add water to the body, which would increase blood volume, increase blood pressure. You already have, in this example, you already have a high blood pressure, so you're wanting to lower it. So this is going to secrete less ADH. The kidneys then will secrete water into the urine. The kidneys secrete water into the urine. That's going to decrease the blood volume, which will decrease blood pressure. Okay, let's look at the fluid shift mechanism. The fluid shift mechanism takes place in the capillaries. If you remember the capillary structure, then we're going to have our arterial end here, the venual end here. The hydrostatic pressure is a result of the blood pressure. So we're going to say that the hydrostatic pressure equals a 40, and then it's going to go down to the venual end, and the hydrostatic pressure is closer to 20. Okay, we remember from this that this is going to push water out of the capillary. And the osmotic pressure is not going to press very much water in. Let's get another color here for osmotic pressure. Osmotic pressure is going to be about 25 here, so you have a small arrow pushing the water in. You have a smaller arrow pushing here because the blood is not as concentrated here in the middle compared to the venual end. Remember that you have plasma proteins and red blood cells that are in the blood, making it more concentrated. Especially plasma proteins, those are the big ones that are going to affect the osmolarity of the blood. Okay, over here on the arterial end, the osmotic pressure gets even lower. The osmotic pressure is somewhere around 15. So you can see that the net movement of water is out of the capillary, so it goes into the interstitial space. Okay, remember that the hydrostatic pressure is a result of the blood pressure. So we're going to increase the blood pressure. So we increase the hydrostatic pressure to, in our example here, we'll do 60. I meant to get a different color. I didn't mean to go to green. I don't want to go to that color either. Hang on. Let's go to purple. Okay. Whenever our blood pressure is going to increase to a 60, then, or blood pressure increases and hydrostatic pressure increases to a 60 as the blood goes into the capillary, you can see that all of our little green arrows that represent the regular hydrostatic pressure get longer with the purple color. And that's going to push more water out. Whenever you increase the water out of the capillary, that is going to decrease blood volume, and decrease of blood volume is going to decrease blood pressure. Why does decrease of blood volume decrease blood pressure? A decrease in blood volume means you don't have as much blood. So if you don't have as much blood, then that's going to decrease the amount of blood going to the heart, and that decreases blood pressure. Next one is renin-angiotensin-aldosterone mechanism. The renin, nope, I'm sorry, atrial natriuretic hormone. We did renin-angiotensin-aldosterone, sorry. Atrial natriuretic hormone. Atrial natriuretic hormone is secreted by the right atrium. It is secreted by the right atrium when blood pressure is high. You could also say that venous return is high. Okay, we're about to quit our video and we'll continue this on the next screen.